Hey guys, today I want to talk with you about OSC. I don't know if you ever heard about OSC. It stands for Open Sound Protocol. And some people say it's gonna be the new MIDI, or it's better than MIDI. It's sort of a future thing. Others say nothing can ever be better than MIDI. Me, I don't really care about that, but I do know that it's a really fun way of combining applications together, and that's basically what it means. So there are a lot of synths and a lot of programs that have already implemented OSC. Reactor has implemented OSC, Logic has OSC. Ableton doesn't have it yet, but you can still use it with OSC2 MIDI converters. So it's something that works on a network. That means that you can talk with computers that are not in your own home. You can address them by their IP address, or you can just set it up on the same computer and let two applications talk together. So I want to start with some very simple examples. Today we're going to use two different programs. We're in Super Collider, which you can see right now, and we have processing, which is a cool drawing application. With Coach you can make animations and stuff like that. So to combine these two programs, there are a few things that we need to do, but first let's just take a look at the very basics. Since OSC has to do with the network, first you have to open a port, a network port that you can address and that you can send the messages to. So in Super Collider you do that by setting the net address new, and then you set the IP address of the computer that you want to connect to. In my case, I want to connect to my own computer, so I use 127.0.0.1, which is always your own computer. And then you do a comma, and after that the port that you want to send the message to. So if I create this port, we can see in the status here that it has created the port, nothing fancy yet. And after that I can send it a message. So for example, I can say here, for example, and there's a cool program that is also free. It's called Osculator, and you can tell it to listen to OSC messages, which you can then map to anything you want. So first we have to define the input port. Since I set 7771 in the net address, this is the out port for Super Collider. This should be the in port of Osculator. So now it's listening to that port already. I can send it a message, and if we switch the window, we can see the message right here. And from here there's a whole lot of stuff we can do with this. We can send it to another address. We can let it run a script inside Osculator, stuff like that. But we're just gonna look at the basic stuff for now. So we've created our net address already. Then I've built a very simple synth. So to quickly go over that, or maybe recreate it, first we create a synth, like with any synth. We'll call it sine synth 2, and let's start with a lowercase letter. Then we're going to give it some arguments. So we're going to define a MIDI note, which is going to be 60, which I believe is middle C, and then we set the gate to 1. That's for the argument. And then for the variables, we want an envelope in there, we want a frequency argument, and we want the signal. Once we have that set up, we need to define these variables. So the first one is freq, and we'll say freq is MIDI.MIDI CPS, and that means that it's going to convert MIDI notes to frequency. So for example, if I do 60.MIDI CPS, in the post window we can see that that is a frequency of 261 point a whole lot of numbers. So this is gonna make it easier for us to make melodies, because now we can think in MIDI notes. So for example, we can go to the 7th semitones, and it will automatically handle the frequencies of that. Alright, then we need an envelope, and we're gonna choose a percussion envelope inside an nggen. So nggen.ar, and then percussion, and then we can set the attack time, something like that, and we can set the release time. Then we set the gate. We're not really going to use the gate because it's a percussive envelope, but we need to have it in here anyway. And then we can define done action 2, which is the action that the synth is gonna take when the envelope has finished, and 2 means free the synth, so don't play it on the server anymore. So that's everything except the signal itself, and for that we're just gonna choose a sine oscillator, and we're gonna give it the argument frequency, and that's enough. And then we send it out to buses 0 and 1, so we have a stereo sound, and we're gonna send the signal to that output, and we'll add it to the server. Alright, so that's our simple synth. If I just play that, I can type synth, and then I'll give the name of the synth, and I can play it. So now I trigger that manually, but I want to trigger that, of course, with my OSC messages. So to do that, I need to set up an OSC dev, which is similar to a MIDI dev. It can listen to OSC messages, and if you type OSC dev, you can already see the information there. We can give it a name. Let's set it to processing listener, because that's the program that we're going to use. And we give it the argument message, which you sort of need in there. And then with this OSC dev, we make the synth. So this is the same thing as we did manually right here, but now we're going to do it with an OSC message. So I'm going to give the name of the synth again, sine synth 2, and then what it's going to listen to, or which arguments you want to send to the synth. So in our case, we're just going to go for the pitch, and remember that we've linked the MIDI to the pitch. Frequency is MIDI.MIDI CPS. So we say MIDI here, and then message, and we're going to go for the first message, and we can multiply this by 40 and then plus 50. This is a bit random, but that's just to make the message a bit higher, the pitch a bit higher, because the input are quite low numbers, and now you get a little bit of higher numbers, higher frequencies. And to make this easier for us to see, we can set it to post in the post window by using the post ln message. So that way we can see the values in the post window on the right side. We close the function. I made a mistake there somewhere. Like that, we close the function, and then we give the word that we're gonna assign inside processing. So that's gonna be called line hit, and that should be between these double commas. I forgot what they're called in English, and then we end with a semicolon. And of course we need to have an opening bracket there as well. So now we can make this OSC dev. We can see that all the values are nil right now, but it did process correctly. So these are the only parts that we need for this tutorial. Don't mind all the other stuff in here. Now we can go over to processing. Might look a little bit complicated, but actually it's pretty simple. We have a very simple animation. I'll rebuild it real quick, so you can see what the important parts are and what everything is doing. First we need to set a float, which is going to have the value speed, and then we set up our image or our animation. And we do that by using a setup function. We set the size of the canvas, so the background, and we can make it 600 by 600. And we set the speed value, which is going to be the speed of the animation, which is 5. And then we get to the draw function. We close this one. If I now run this animation, you can see just a blank canvas of 600 by 600 pixels. So then we want something in there. And to do that, we type void draw and opening bracket. We can set the size again, but we really don't have to actually. And we can set the frame rate, which is the speed of the animation. And we can set the background color. If we set it to 0, we give it a black color, because it has no color, 0, which basically means black. and then stroke is the color of the objects in the canvas, and if you set it to 255 it's going to be white. And then we need to declare some variables for our line. We're going to make lines, so I'll just copy this over. We have a horizontal line, we have a vertical line. So the way this works is if you make a line object here, so a line always needs 4 values. The first value is going to be of the first point, and then you have the x and the y position, so 10, 10 for example, and then for the second point you have the x and the y position as well, so 80, 80 for example. And if I just run that, we can see our line right there. And now it's just a static image, but we want to change this, of course, into a beautiful animation. So the first thing we do is we set these variables, and then we need to make it move. And now because we've set these the points of the lines to a random position, that means that it's going to be different every time a new image gets drawn. New image gets drawn 10 times a second, because that's the frame rate. I can make this slower, I can make it one time a second or 2 times. And it's going to be on a random new position every time the new canvas is drawn and the new background is drawn. So you can see right there it creates all these lines. If I set the background to black, that would be easier to see for us because the lines are white. You can see there the random image. If I don't set the background right here, but if I set the background in the setup function, which is not a moving function, then you can see that the lines keep adding because the background doesn't get refreshed. So the image keeps building. It's getting random positions for every frame rate, but the background isn't refreshing. So it looks less like an animation. It looks more like building blocks. But if I set the background right here, the background will refresh after every line, and that means that we only have one line at a time. So that is a very quick overview of how processing works. So now we have to bind this to SuperCollider, and to do that we import this OSC library, and we do that by saying import OSC p5 and net p5 for the net address. Then we declare 2 variables. OSC p5 is going to be OSC and net address is SuperCollider, and that's just to change these names to something that we can easily remember. Then we initialize these variables. So first we initialize the OSC and then the SuperCollider, which is going to be the address and the port. And then the last thing to make that all work is to make an if statement. And in our case, we're going to say if the L vertical is less than 100, we can see the L vertical 2 right here, which gets random values between 100 and 600, then send these messages. And then it's gonna send the address line hit. So this is what normally would be your CC number if you're using MIDI. This is just the address that it's using, and then it's gonna send the message, so the actual values. So let's try that. And then we can actually hear our SuperCollider playing that. And the one thing I forgot here was to map this to our envelope, so we can do it right now. Times envelope and times 0.3 to make it a little bit softer in volume. And then we run our OSC dev, and then we run our image. So that way we get not very interesting sounds, but I hope you can see that the technique behind this, or the creative approach behind this, is actually pretty cool. So what we can do right now is we can set the frame rate to a different size. That's a very easy thing to do, which is right here. We can set it to 9, for example, to make it a lot faster. And we can very easily change the synth. I have another synth right here that I can call by just naming the OSC dev differently right here. and then running our image again. So as you can imagine, there's a lot of stuff you can do with this. I hope this example was not too complicated. You can also start a lot easier by just combining this with the reactor. For example, if you don't know any of these programs, it might be a bit difficult to learn 2 new programs at the same time, or if you're not very familiar with code. So you might just start with processing, which is very easy and very well documented free software, so you can download it whenever you want. And you can combine it with Reactor as well, or things that you might already be familiar with. Other things you can do is you can make interfaces and let them talk over OSC with your DAW, like Ableton. That's the way those apps work. You have those iPad apps that you can control Ableton with. One is called Live OSC, I think. You have the Touch OSC editor, you have Live Control. There's a lot of options coming up lately for OSC binding of applications, and it's very interesting. So with this, I just want to get your feet wet and let you know about it at least. And now you can maybe look into it yourself. If you have any questions, let me know. I'll try to make some more tutorials in the future, and we might start a little bit easier and then we build our way up to the more advanced examples. Thanks for watching, and see you another time.